Lesson 9-5, we are learning how to deal with the slope-intercept form. The essential question for today's lesson is, what is the fastest but accurate way to graph a line? So we're going to learn how to do that today. But first, let's pay attention to this form right here. It's called standard form, and standard form is exactly this right here. Here's a great example of standard form. Standard form is when your x value and your y value are on the same side of the equal sign. So these are together on the same side of the equal sign. Now that's fine, but we need to change them into or to the slope-intercept form. And to do that, we're going to use what we learned back in Unit 2. So first, we need to, or before I start, the idea is to isolate y. So y is right here, and we need to get everything away from it. So let's first remove the 2x by adding a negative 2x. That's the inverse operations. And then we're going to do the property of equality. And you can see that 2x plus negative 2x is 0, and 4y comes down. And we have negative 2x plus 8. Now I like to put the x's right behind the equal sign. So it says 8 plus negative 2x, and I use the commutative property and put negative 2x plus 8. It's the same value. All right, so let's deal with the 4 now. So we're going to divide by 4. That's the inverse operations of multiplication. And if you do it to one side, you do it to the other. 4 divided by 4 is 1, and you can see that y is now isolated. And over here, we have negative 2x divided by 4. So let's study that just a little bit. Negative 2, supposed to be a negative sign, negative 2x divided by 4. Well, if we were just looking at this right here as a fraction, negative 2 over 4, that can be simplified into negative 1/2. We'll keep the x here, and another way to write this is negative 1/2 x. So we'll write negative 1/2 x, and then we'll do this on the back here. 8 divided by 4 is plus 2. This right here is known as slope-intercept form, when your y is all by itself and it's positive, no other signs, is equal to an x value most of the time and a constant. Let's try it again. This is standard form 2. We have a subtraction sign here, so we'll deal with it, additive inverse. You can see it is standard form because we have an x value and a y value on the same side. So let's deal with the x value first. We will add a positive 5x to both sides. That will give us a leftover of negative y is equal to 5x plus 10. Then we need to remove this negative sign. Remember, there's a 1 right in front of the y, so we're going to divide by negative 1 on both sides. A negative divided by a negative leaves the y positive and by itself. 5x divided by negative 1 is going to give you negative 5x. And 10 divided by negative 1 is going to give you negative 10. Now, there's a better way to write that, as you know, and that is y is equal to negative 5x minus 10. And that is slope-intercept form. One more example. These y's and x's are on the other side of the equal sign, but since they're together, they are still in standard form. So we're going to go down to the subtraction sign and do additive. Additive, inverse. We want to remove the 2x by adding a negative 2x to both sides. And that leaves negative 4y on the right side. And on this side, remember we want to have the x term in the front, negative 2x plus negative 12. Now we're going to remove the negative 4 from the y by dividing by negative 4. And this is very similar to the very first one. A negative divided by a negative is a positive, so that's going to be a half x and then a negative 12 divided by negative 4 is going to be positive 3, and that's all going to be equal to y. Now to write that into slope-intercept form, we do y is equal to half x plus 3. So that's how you change equations into slope-intercept form. Let's talk more about slope-intercept form. What is it? It's this right here. That's slope-intercept form officially. Y equals mx plus b. Now that m is attached to the x by multiplication, and in our very first unit, we learned that that spot right there, that m right in front of the variable, is called a coefficient. And we also learned that this b on the trailing end, what used to be blue before I highlighted it, is called the constant. It's all by itself. Now this m and the b have different names in slope-intercept form as well. M is actually the slope. And you learned a little bit about that in a recent lesson. And the b is called the y-intercept. Now, what is this slope? Well, slope is m. You can see so. It's a ratio. It's a ratio of rise over run. Right? Oops, not that. Rise. Nope. Try it again. Hold on. Rise over run. Okay, so what is rise? Well, rise has two meanings. It means going up usually, but it also in math means going down. So you can either go up, that's why the arrow is pointing up, or you can go down. It's like an elevator, going up or down. Now up is a positive direction on a coordinate plane, and down is a negative direction on a coordinate plane. The run, you can go left or right. The right, when you go to the right on a coordinate plane, is positives, and when you go left on a coordinate plane, it is negatives. All right, this ratio that we just talked about right here it's a ratio of, I should say, the vertical change over the horizontal change. And if you remember back to a previous lesson, we had a triangle y, that's vertical change over horizontal change, delta y divided by delta x. And then we learned that this was this. That's how you found it. You needed 2 points. You need your second point, your y from your second point, minus your y from your first point. And then you need your x from your second point minus your x from your first point. And you just subtracted those, and then that's how you would find the slope. All right. Remember, why was m chosen for slope? Well, I don't absolutely know, but I do know mountains have slopes, so I'll draw a little skier here. That might make you remember that mountain have slopes, so m means slope. Let's talk about the b. The b is known as the y-intercept, and the y-intercept is actually a location. It's a location of the line, so it's a line passing through the y-axis. Now the y-axis on a coordinate plane is the vertical one. Don't know how that arrow happened, but I'll use it. Okay, we have a y-axis here, and we have an x-axis here. And if a line is drawn anywhere on the graph, it will pass through the y-axis. Remember, the y-axis is this one right here. So it might pass above the x-axis, or it might pass below, right here, or it might even pass right on the x-axis. So it will pass through the y-axis somewhere at some time, and that's known as the y-intercept. All right, we've covered everything that we need to know, and now we're going to do a comparison and start practicing what we just learned. So here in this section we have a graphing comparison, and our comparison is going to be between graphing with ordered pairs versus graphing from slope-intercept form. All right, in this box at the top we have an equation, and this equation is in standard form. So let's fix it up into slope-intercept form. By removing the x term, we're going to add a positive x, that's inverse operations, and then we're going to do the property of equality and do it to the other side. We're going to get 2y is equal to 6x plus 6. We will divide both sides by 2, and y is equal to 6x divided by 2 is 3x, and 6 divided by 2 is 3. And that is slope-intercept form. All right, now once we have slope-intercept form, we're going to come over here and make a table. So, you're very familiar with this too from recent lessons. We have an x and a y. And our favorite x's to use most of the time are simple ones for math. -1, 0, 1, and 2. Right up here, we're going to insert our rule or our function, 3x plus 3. And that's how we find our y's. So let's rewrite that as 3 parentheses for the x plus 3. And we'll do that 4 times. And in these parentheses, you put these numbers. So -1 goes here, then a 0, then 1, and 2. And now you just do the math. So 3 times -1 is -3 plus 3 is 0. This is going to be 3, and then a 6, and a 9. All right, now we're going to make ordered pairs with what we just found. So our ordered pairs have parentheses with a comma. Our first one is -1, 0, then 0, 3, then 1, 6, and then 2, 9. Now we have our 4 ordered pairs, and we go to the graph, and we graph them. So -1, 0 is here, 0, 3, 1, 6, and 2, 9 is just off the graph. So it's not a totally trustworthy point. All right, so we take these right here. We line up something straight like your ID card or a ruler, and you connect all the points in a straight line because it's linear. Put your arrows on the top and bottom, and you just graphed your first line. All right, we're going to see how that graphing with ordered pairs, and our ordered pairs are right here to make a line, is any different than graphing from the slope-intercept form. But first, we have to take this standard form and make it into slope-intercept form. Now this problem is the same exact problem as upstairs on this one, so we'll just do it even faster. We'll add 6x. 2y is equal to 6x plus 6. We'll divide by 2, and y is 3x plus 3. We're ready. Now let's talk about this for a second. This right here, plus 3, or just positive 3, is known as the b. And the b is the y-intercept. The 3 is known as the m, which is the slope. And slopes are ratios. So we're going to spread out over here, and we're going to write 3 as a ratio, and that's 3 over 1. And b is the y-intercept. And the y-intercept for this one is 3. Now, what we want to do first is always graph the b first. B always comes first when you graph. So we're going to go over here, and it was a 3, and that 3 is located on the y-axis, and the y-axis is right here. So positive 3 is located right here, so we make a nice little point. Then, the second thing we do is we graph the slope. And the slope is 3 over 1. And remember, the top number, since it's positive, means we are going up. And the bottom number, since it's positive, means we're going to the right. So we start at the top and work our way down. So go to this point, and 3 up means 3 up. 1, 2, 3. We started from the y-intercept, and we go to the right 1. 1. And that right there is our point. Now we have 2 points. That's all we get. And so we're going to graph this line. And if you look, if you compare both lines, they are exactly the same line. So you can see there's one way that takes quite a bit of work, which is making ordered pairs. You got to make tables, then you got to make ordered pairs, then you got to graph them. But however, on the contrast or comparing this, we just made this into slope-intercept form, and it gives us the tools we need to go immediately to the graph, and so we get to bypass all the tables and ordered pairs. So that's what we're going to be practicing today, is how to graph from slope-intercept form. Now sometimes, as you're graphing from slope-intercept form, you're going to run into some problems. What if the graph runs out of room? Well, these graphs are small like this, and that's on purpose because I want you to witness what happens when you run out of room. Before we begin, we have y equals negative 2x minus 3. That is in slope-intercept form, so we can graph. So I'm going to do additive inverse to this, and I can see here that I have my b, and I also have my slope. So we always start with our b first, and that's negative 3. So on the y-axis, the b is located down here at negative 3. Okay, that's done. And now I need my slope, which is negative 2. Well, negative 2 as a ratio is negative 2 over 1. And you can see that negative 2 on top means I'm going to be going down 2. And the problem with my point on my graph is I have no more graph to go down. I mean, I could go down, but it might not be very accurate. So what is also equal, oh sorry, I didn't finish my thoughts here. The bottom one is to the right because it's a positive number. So back to the previous thought. What is equal to negative 2 over 1? 2 over negative 1. Now let's examine this just for a second before we move on. Negative 2 divided by 1 is officially negative 2. And this one over here, 2 divided by negative 1, is actually also officially negative 2, because a positive divided by a negative is negative. And so you can see that these two are equal. The second one that we made, this is a positive on top, so now we don't go down, we go up. And the bottom one's negative, and we don't go right anymore, we go left. And that's going to give us the room we need, because we have room to go up. So we go up 2, 1, 2, and then we go left 1. And we're going to repeat that slope over and over. Up 2, left 1. Up 2, left 1. And you can see when you repeat the slope multiple times, you have lots of points you can line up to draw your straight line with your straight edge, your ruler, ID card, something straight. Let's practice this one more time. This is in slope-intercept form, so that's nice. Our b is 2, so we can go on the graph immediately, go up to 2 on the y-axis, and graph our b, also known as the y-intercept. Now, our slope right here, which is m, is 1.5. That's not a ratio, so we need to multiply the bottom and add the top to make it improper. And that is 3 over 2. And 3 is positive on top, so that means we go up, and positive 2 on the bottom means we go to the right. Now when we're working with this, we don't have enough room to go up. So what is also equal to 3 over 2? Negative 3 over negative 2, because a negative divided by a negative is a positive. So these two are equal. So the negative on top means you go down, and the negative on the bottom means you go left. All right, so let's start at our y-intercept and go down. 1, 2, 3, and then go left 2. 1, 2. And that's about all the room we have to make this line. Put your arrows top and bottom. So those are two examples of what you should do when you run out of graph. All right. Your notes may look like this, or you may have a different graph. If you have a different graph, that's okay. It will work just fine. So, graph each equation using slope and the y-intercept. So this is set up nicely for us. We have a b and we have a slope. So we're going to go on our graph and we're going to go immediately to the y-intercept and graph 1. From that point, we're going to graph our slope, and our slope is 4. 4 as a ratio is 4 over 1. And we have plenty of room to go up. So we're going to go up 4. 1, 2, 3, 4. We arrived at 5 because 5 is 4 away from 1. And then we're going to go right 1. Remember, we went up positive and right positive. Let's repeat that again. 1, 2, 3, 4 over 1. All right, it looks like we're going to have a nice points to graph our line. But what is also equal to 4 over 1? Negative 4 over negative 1. And that's down and left. So let's go back to our y-intercept and go down 4. 1, 2, 3, 4, and left 1. And you can see, as we do this over and over, these points are actually lined up as well. So the more points you have, the easier it is to draw your straight line. Now my line isn't very good, but with your straight edge, you have total control over it. With a computer, I do not. Let's try another one. This one here is y is equal to negative half x minus 9. Okay, I had to pause the video and do a little research. I did change this value right here. Your notes might say 9. If you have a 9 there, you have the old notes. I actually changed it to a 5. So the b is now a 5. So if you have the old notes like 9, then please change it. All right, so let's go ahead and start. We have here y equals negative half x minus 5. So I'm going to use the additive inverse. And that's my b is now a negative 5. So I'm going to go down to negative 5 on my graph. And your graph might look different, but use it just the same. And my slope is negative half. Negative half. That's also equal to negative 1 over 2, and that's also equal to 1 over negative 2. So I got a lot to choose from here. I'm going to work with this one first. Negative 1 over 2. So that means down 1, right 2. Down 1, right 2. Down 1, right 2. And that can take me all the way to the corner of the graph. Then at the top, it's 1 over negative 2. So I'm going to go up 1 over to left 2, 1 left 2, 1 left 2. And those all should also line up. Now I have plenty of points here to make my nice straight line. I put my arrows on the top and bottom, and it's graphed. On this one, you can see that your B is missing. It's gone. So is it really gone, or is it there? It's there. It's plus 0. So my y-intercept is actually at the origin. So let's put a point at the origin. And my negative 3 is a slope, and that's negative 3 over 1, or 3 over negative 1. So let's use the first one. Negative 3, 1. So that's down 3, right 1. Down 3, right 1. And you just keep on repeating that. Now use the next one. That's up 3, left 1. Up 3, left 1. Up 3, left 1. Up 3, left 1. And you can see that all of these are lined up. Whoops. I pulled it off, so sorry about that. Make sure your line covers your points. All right, I also modified this one. Your notes might say the negative 27 like you see on my screen, but it is actually a negative 15. I changed 27 into a negative 15. So go ahead and change that real quick before we begin. And this is a problem. This is in official standard form, so we can't graph it, so we need to change it first. So I'm going to change, I'm going to smush all this stuff together up here. This is going to be additive inverse. I'm going to remove the 4x by subtracting or adding negative. Can you see that's negative 4x? And then add a negative 4x to this side. All right, now I'm going to have negative 3y is equal to negative 4x plus negative 15. And now I need to remove the negative 3 by dividing by negative 3 on both sides. And you can see my problem is going to be y is equal to negative 4x divided by negative 3 is actually 4/3 x, and negative 15 divided by negative 3 is going to be 5. So now we have our b and we have our slope. So let's go down and do our b first. The line will be crossing the y-axis at 5. It's right there. And then our slope is 4/3, or 4/3. So we're going to go up 4, 1, 2, 3, 4, and then over 3, 1, 2, 3. Now we've run out of graph already, so what is equal to 4/3? Negative 4, negative thirds. So that means down 4/3. Down 4/3. Down 4/3. And that's plenty of points to graph. I have a problem because my points aren't lining up. Let's investigate. I moved 4/3. I have a problem right here with this point. I went down 4 and I only went over 2, so that is not correct. Since that one's wrong, it also threw off this one. So let's start again. 1, 2, 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Now let's try graphing those. There we go. My line covers all of them, so now I know I have it graphed correctly. Make sure you have your arrows bottom and top. All right, on this next one, you see something else missing. You can see that we're missing an x. And so let's just move it over. And if we're missing an x, it probably is something to do with the slope. And if the x is gone, it must have been multiplied by 0. And our b is still, with additive inverse, is negative 7. So we still have a b at negative 7, so let's go there. Count down to negative 7. And let's go ahead and go to this next part here would be our slope. Up 0, so that doesn't mean you go up or down. That means you just stay where you're at, but you move to the right 1. So move to the right 1. 1, 1, 1, 1, 1, 1, 1, 1, 1. And you can see it's not quite flat, but it's meaning to be perfectly flat. And that is 0 slope. It's flat. So that makes a lot of sense. And finally, this last one looks like it's almost ready, but we have a negative y right here. So let's get rid of that negative y. We know there is a 1 in front of it. So we're going to divide this side by negative 1 and this side by negative 1. And what we get is y is equal to 5x divided by negative 1 is negative 5x. And 8 divided by negative 1 is negative 8. And now we are ready to graph with our b. So we're going to go all the way down to negative 8 on the y-axis. Then we're going to take our slope, and our slope is officially negative 5/1. Well, I don't have any more room to go down, so I need to translate my slope in something I can use. Right now it is negative 5 over positive 1, and that's equal to positive 5 over negative 1. Now I can go up 5, left 1. 1, 2, 3, 4, 5, left 1. 1, 2, 3, 4, 5, left 1. 1, 2, 3, 4, 5, left 1. And it looks like I'm running out of room then. So I draw my line, and it looks like they cross over each point. That's how you graph lines. Let's take a look at a bit of your homework or your assignment. First name, last name, date, and period. That always goes first. Number 1. The directions state the slope and the y-intercept. Well, remember what the slope is? It is m, and the y-intercept is the b. So this is already set up, and so the slope here, m, is, what is it? 1. So I just write a 1. Now, you might want to be thinking, well, don't you have to write it as 1 over 1? Well, when it's just a single digit like that, we don't transfer it into ratio. We just say the slope is 1. And we know that, we understand that it means this. So in the form, you're officially just going to write this for your answer. Nothing else, just a 1. On number 3, you can see that we're missing something. We're missing the b. So that's plus 0. You know, I didn't even finish number 1 yet. Here we go, let's go back to it. This is b. And what's the b on this one? It is 9. So on the form, you officially just write 9 for the y-intercept. Now let's go to 3. The slope here is officially negative 6. That's your m. And your y-intercept is officially 0. And that's what you would write into the form. Just negative 6 for the slope and 0 for b. On number 5, you're going to officially write 8 for b, the y-intercept, and you're officially going to write 1/3. And when you do that, if you remember in the forms, you do 1/3, and that means 1/3. Watch out for number 6. It's not ready to be entered in because that's standard form, so work on that first. After you finish those, which are really quick, you go down to number 7. It says graph each equation using the slope and y-intercept. But on these graphs, they don't have y and x-axis, so you got to draw them in. I like just going to the center one and drawing my axes. Now you can always move them around, or you can number it by 2s or by 5s or by 10s. It doesn't really matter. This is such low numbers that it's going to work just fine. So we have additive inverse here. We'll go down to negative 2. And our slope is 3 over 1. So up 3 over 1, up 3 over 1. And our line, yeah, it's a terrible line. Let me try again. That's way better. Is right there. But on the form, you're not going to be graphing. I'm going to ask you again what the slope and the y-intercept is. For in this case, the b is actually negative 2, and the m is actually 3. And again, that's what you would just put in the form, just the numbers. I think there's one more odd number here. This one's not ready to graph because it is in standard form, so we need to work on it first. X minus y is equal to negative 4. So we'll do the additive inverse here. We'll remove the x by subtracting x or adding a negative x. Either way works. We get negative y is equal to negative x plus negative 4. Now we need to remove the negative sign, and we know there's a 1 there, so we're going to divide by negative 1 on both sides. And now I have my nice positive y is equal to positive x plus 4. So now I'm ready to graph. I need my y-axis, and I need my x-axis. We're crossing the y-axis at 4, which is right there. And my slope is 1 over 1. So I don't have a lot of room to go up, so I go up 1 over 1. Well, what is exactly equal to 1? Give you some more room. 1 over 1. Negative 1 over negative 1. So we're going to go down 1, left 1. and you're going to see you're going to run right along this area here. Draw your line, put your arrows, and call it good. Now, remember in the form, you won't be graphing. It's going to ask you for the same thing. And officially here, the y-intercept is 4, and the slope is 1. And that's what you would put in to the form.